Development requires a software that's collaborative by design, able to facilitate the handoffs in between the number of teams involved in development. Additionally, development needs a software that balances flexibility and rigidity. Flexible as you're undergoing process development and the process is changing, and rigid once that process is locked down to standardized data capture. And we're going to illustrate today how Benchling can help with those challenges. We've developed a best practice around Bioprocess and Bioanalytical teams and how they can use the Benchling platform. So we'll start today with Bioprocess. Scientists from the cell line development team, upstream and downstream, as well as formulation, can all work on the Benchling platform, as well as the analytical chemistry group. Benchling can help facilitate those handoffs in between the teams and with the analytical chemists. So I'll step into a few personas today. First, showing you how some of those scientists in the functional groups from cell line development and upstream and downstream can use the Benchling platform. And then how an analytical chemist can receive requests and samples and do their own assays on Benchling. And finally, I'll show you how an admin or a manager can come in and update the platform easily, as well as glean insights about what's going on in the science that's happening. So I'll start today as a cell line development scientist, having recently received an update that there are some new cell lines for me to make and clones to select. As I come into a Benchling entry here, I can see that this is locked down and standardized, but allows me to capture all the key parts of my work that are needed. So I'm able to easily capture new clones that have been made, any banks of those, their plates, as well as key results on them. Benchling for lab automation also supports integration with instrumentation in the lab. So here, those clones that were sorted and plated are automatically captured on Benchling from that liquid handler. The new clones are registered and linked back to their parents, and the plates are created as well. Similarly, Benchling for lab automation supports integration with analytical instruments. So my octet data, as it comes off the reader, automatically comes in and is associated with each of those clones. Finally, because all of that data is structured and captured on Benchling, I'm easily able to look at reports that tell me the results across all of my clones. I can see the titer across any clone that has been plated today, as well as I can look at specific clones that had outstanding antibody titers or an aggregation of the results for those. Once cell line development is complete, Benchling facilitates that handoff to upstream and downstream teams, so we can kick off our protein production run. So as you can see here, we've done just that and started a bioreactor run. Similarly to the cell line development teams, we're able to take advantage of Benchling's rigid yet flexible structure. The admins have set up a template for the bioreactor teams to capture their data. And I'm able to confirm any steps that are done, capture the media that's been prepared and the lots used, and anything about the run itself, the conditions for setup, as well as online and offline data. Likewise, for the protein purification team, once that handoff occurs on Benchling, I'm able to start that purification process, capture any of the information about it, as well as key results like the final titer and volume that come off of it. And of course, it's similar for the formulation teams as well. And throughout this whole process, any of these teams are able to easily place requests to the analytical chemistry team. You can see here directly from my notebook, as I pull off those in-process samples, I'm able to place those into a new request. And likewise, once that request has been made, able to easily see what the status is of the tests that I've requested and any updates. I'll now step into the shoes of an analytical chemist who has received these requests and in-process samples from the other teams. So we can see here that I can easily view any of those requests, what day it's due, as well as the samples and metabolites requested to be quantified. I'm also able to view across the requests, so I can easily group the work for our team, look at what samples and assay panels were requested across all of them, and group those to be assigned to individuals. As an analytical chemist, I can take advantage of Benchling's notebooks again to capture all the steps in my work, any of the sample prep, as well as the assays run, whether that's mass spec or HPLC. Benchling for lab automation also helps bring back in those results via an integration with each of those instruments. And finally, once the work is done, I'm able to complete my work, and it's pushed back for each of those requesters. So while each of the chemists is grouping according to the panels that they want to run and their assays, the requesters are seamlessly able to see the results that they care most about, against their own samples. Now that we've followed a bioprocessing run through, what does Benchling look like for the admins and managers on these teams? So that you can see that Benchling supports full entry, review, and sign-off. Here I have a locked down entry that has been reviewed by specific criteria and signed off to be locked down for legal purposes. Each of these entries that we showed today can all be configured by point and click. So if I want to be able to make an update for one of the assays that my team is doing, or adjust the results that they should be capturing, that's very easy for me to add in a new table or new column and publish that new template to be available the same day for use by those scientists. And finally, one of the benefits of having all of this information end-to-end in one place is I can glean insights about the science that's happening. Coming to an insights dashboard here, I'm able to see the results aggregated across an entire candidate run from end to end, as well as across runs. Likewise, operationally, Benchling can help you understand what's happening with your teams. Seeing the data on the type of requests and how often they're replaced to specific teams and from whom, and also understanding the sample and counts for each of the teams as they're processing them, and also by program. Now that we've seen our bioprocess best practice, let's jump into bioanalytical. So showing a brief overview of the bioanalytical team's work, this can vary from everything from methods development and validation to study planning, receiving the samples, of course preparing them, running those assays, and reporting back the results. And Benchling is able to capture all of this information end to end. As we come back into the product here, similar to the analytical chemistry team, each of those requests placed to the bioanalytical team can be viewed all in one place. I have the flexibility to assign it to the scientists on the bioanalytical team so that they might be completing an end-to-end scientific process, or it can be split up by the specific steps for sample prep or receipt, or by assay type for an ELISA or for sequencing that needs to be done. As we come into each of those steps, they can be captured inside of the Benchling notebook. So everything from sample receipt and updating about information on the shipment or conditions of the samples, through sample preparation and any of the new samples that are made from the initial one received or the tissue preparation that needs to be done. All the way through running each of the assays. You can see here we have a ligand binding assay for an ELISA in this case, and I'm able to easily capture both the conditions and the results of that assay. And of course, integration with instruments can make the capture of those results seamless and not requiring manual intervention from the scientists. Benchling configurability means that, well, in this case, we're showing you an ELISA assay. Benchling templates can be configured to capture any of the assay types done by a bioanalytical team, whether that's an ELISA or FACS or a sequencing run that needs to be done. And finally, because everything is aggregated on Benchling, I'm able to understand insights from the team about what's going on. So scientifically, looking at a report of results for a specific request, or how consistently assays and controls are reporting out. Operationally, I'm also able to understand the throughput and efficiency of each of my teams, as well as how many requests are coming in by each program. As we saw today, Benchling empowers these use cases that were traditionally supported by legacy LIMS or LES solutions, although we have so much more to offer than these legacy solutions. In productivity, because it's one unified end-user experience across the process, scientists don't have to waste time switching between point solutions or reconciling data between softwares. In collaboration, Benchling's cloud-native architecture compared to legacy on-premise systems means that disparate teams across many locations can seamlessly collaborate. In fact, we're designed from collaboration for the ground up, with workflows now facilitating those handoffs between teams. Additionally, Benchling can provide new insights. Because of its configurability, each of these teams that historically may have had to be on their own custom solution are all on one platform. What that means is that the end-to-end process is captured in one unified data model. And so scientific overviews and insights, as well as operational summaries, can easily be queried. And this can be done longitudinally across the data. And finally, Benchling is agile. As we saw, it's easy to make updates to a template as the science changes, easily capturing new data or new process of an existing scientific flow. Additionally, Benchling supports across many modalities, so it's able to expand into new scientific areas as you do. The best practices that we shared with you today for Bioprocess and Bioanalytical were developed with our leading customers who are using Benchling for these use cases. These give customers a starting point for their configuration, speeding up rollouts, and can then be tailored to the specific scientific workflows that you're doing. Additionally, the flexibility of Benchling means that we can support not just protein and antibody development, as we saw today, but other modalities as well, like cell and gene therapy. We're excited to share these with you today and to see what our customers will do with them.